Well, now we continue with the mechanical properties of the solids. When we use this term mechanical properties of the solids, we are basically referring to the elasticity, the elastic constant, the stress and strain on the body, then what is bulk modulus. All these facts we have to go in the mechanical properties of the solids. The very first thing which we are going to discuss now, that is the Poisson's ratio. Earlier, we have discussed about the concepts like stress and strain, longitudinal stress, longitudinal strain, and now we come towards the Poisson's ratio. That is, we are referring now the longitudinal as well as transverse sections of the body. So we come to the main concept, that is the change per unit length of the body in direction of the applied force is called longitudinal strain. So before proceeding further, I will explain the fact that is change in per unit length. That is, we apply some force and the change in length takes place, and that change in length takes place in the applied force. The direction of the change in length will be depending upon the direction of force. So if force is applied from left to right, it means longitudinal strain will be from left to right, and it is designated by alpha. So again, I come to the main concepts. The change per unit length of the body in a direction of applied force is called the longitudinal strain, that is alpha. The change per unit length of the body perpendicular to the direction of applied force is called transverse or lateral strain, that is beta. So we have got now two representations. One is alpha, other is beta. Alpha is for the longitudinal strain, beta is for the lateral strain. So strain means basically the change in shape to the original shape. So longitudinal strain means that is there will be change in shape lengthwise, and when we speak transverse lateral strain, it will be perpendicular wise. So next now we come to that within the elastic limits. That is, we have to not cross that elastic limit, because elasticity is the property of the material due to which body comes back to its original position when the applied force is removed. So within elastic limit, the ratio of transverse strain means perpendicular side and the longitudinal strain is constant. It is called Poisson's ratio. So Poisson's ratio means we have to take the ratio of the transverse strain and the longitudinal strain. Transverse strain means in the perpendicular direction and longitudinal means lengthwise. The ratio of the two strains under the elastic limits will be known as the Poisson's ratio. So it is shown in the figure that original length of the body is given as L, D is the diameter, and there is a wire indicated by dotted line here, small d, that is the change in thickness, and F is the force applied. So the original length is being given, that is L, and F is the force applied vertically downward. That is called transverse strain. So that force is giving rise to the transverse strain, and as a result, the change in length takes place, and the change in length will be L. So the ratio of the transverse strain to the longitudinal strain, transverse means perpendicular wise and longitudinal means lengthwise, is always constant. So that ratio is called the Poisson's ratio. So Poisson's ratio is given by function sigma is equal to beta by alpha. Beta and alpha, these are the two symbols for the lateral strain, that is the transverse strain, and alpha for the longitudinal strain, as it is clear from the previous portion. Now sigma is unitless and dimensionless quantity, because whatsoever is the unit for beta, the same will be the unit for alpha. So units will cancel off, and we find that sigma has no unit. So obviously it has got no dimensions. So it can be taken as m naught, L naught, T naught. Next is theoretically sigma is between -1 and zero point 0.5. So that is the range of the sigma given, that is from -1 to zero point 0.5. That is the variation is very small, only point that is from -1 to 0, then from 0 to zero point 0.5. But in practice, its value lies between zero point 0.2 and zero point 0.4. So 0.2 and zero point 0.4 is generally taken as 0.6, and the average value will be somewhere near 0.3. If due to change of length delta L of a body, there is change in the area of cross section delta A, and the change in volume is delta V, then delta V can be taken as delta A multiplied by delta L. That is, the area multiplied by length gives the volume. So change in length multiplied by change in area, that will give the change in volume, that is delta V. So again in the figure it is shown here, that is the change in length will be assumed as delta L, and change in area of the wire will be taken as delta A. So change in volume of the structure will be delta V. So this is what I have suggested earlier. Delta V is equal to A minus delta A into L plus delta L, and from the total we subtract, that is minus AL. The product of AL is basically volume. So A minus delta A and L plus delta L gives the volume, and from this volume we subtract AL. Now AL, that is, it can be taken as delta L by L minus delta A by A, and other number will be delta A by A equal to 2 delta D by D. So these are all the mathematical investigations regarding the Poisson's ratio, which is beta over alpha. So change in volume to the original volume, that is taken as that is a change in area multiplied by change in length. So it is given in mathematical form, that is delta V over V is equal to delta L over L into 1 minus delta A over A divided by delta L over L. This is equal to delta L over L after taking the LCM within the brackets 1 minus 2 sigma, and sigma will be taken as the Poisson's ratio, and that will be beta by alpha. Sigma is taken as half of 1 minus delta V over V, that is change in volume over original volume, multiplied by original length over the change in length. That is equal to half of 1 minus delta V over A multiplied by delta L. So after all cancellations, our conclusion is, that is the Poisson's ratio, sigma is equal to half within the bracket 1 plus delta V over A delta L. A delta L means delta L is a small change in length.